In this video, we'll be solving a quadratic inequality. A quadratic inequality is any inequality that can be written as ax squared plus bx plus c is less than 0. Now remember, we can substitute any of our inequality symbols in for this. What I'll do is I'll write out the steps for solving a quadratic inequality on the left here, and then I'll actually do those steps on the right using the inequality x squared minus 2x minus 15 is less than or equal to 0. Now our first step is to solve the corresponding quadratic equation. So our equation is x squared minus 2x minus 15 equals 0. Now this is factorable, so I will solve it by factoring. I need an x in both of the first spots, and then I need two numbers that multiply to give me negative 15 and add to give me negative 2. And I think that negative 5 and positive 3 will do the trick. So let me check. Negative 5 times 3 is negative 15. And then a negative 5x and a positive 3x does add up to give me a negative 2x. So whenever we have two factors multiplied together and their product is 0, then I can let each of the factors equal 0, or x plus 3 equals 0, and solve those separately. So add 5 to both sides here, and I have x is equal to 5, and subtract 3 here, and those cancel, and x is equal to negative 3. So these are the two solutions for the quadratic equation. Now we want to identify the intervals determined by the solutions of the quadratic equation. So I'm going to draw a number line, and I have two solutions. Negative 3 needs to get graphed here, and then 5 will get graphed here. So my intervals that I'll be working with is all the numbers less than negative 3, all the numbers between negative 3 and 5, and all the numbers greater than 5. My next step is to use a test value from each interval to determine which intervals form the solution set. So I just need to pick one test value, and all of the numbers in that interval will behave the same way as the test value. So numbers that are less than negative 3, let me use a test value of negative 4. And then numbers between negative 3 and 5, I'll use a test value of 0. And then numbers that are greater than 5, I'll use a test value of 6. So I need to put those back into my inequality. X squared minus 2x minus 15 is less than or equal to 0. Let me write that again so I don't need to keep moving my paper. X squared minus 2x minus 15 is less than or equal to 0. And I'm going to test each of these intervals. So I'll put my test value into this inequality and see if it works. So negative 4 squared minus 2 times negative 4 minus 15. And I want to see if that's less than or equal to 0. So I have 16 plus 8 minus 15, and this is 9 And I can see that that is not less than 0. So this interval does not work. Now I'll use a test value of 0. So 0 squared minus 2 times 0 minus 15. I want to see if that's less than or equal to 0. So 0 minus 0 minus 15. Negative 15 is less than or equal to 0. So this interval will work as part of my solution set. And then let's check the test value 6 in this inequality. So 6 squared minus 2 times 6 minus 15. And I want to know if that's less than or equal to 0. 36 minus 12 minus 15 is 9, which is not less than 0. So this interval does not work. So my solution set is going to be this interval between negative 3 and 5. You have a number of ways of writing your solution set. If you were asked to show the graph, that would just be a number line with our negative 3 and our 5, and we have to show numbers in between negative 3 and 5. And then let's see, I want, since this is less than or equal to, I've got that little line underneath the inequality, I need to include my endpoints, which means I need a squared off bracket for both boundaries. And that will say include those numbers in the solution set. Right? If I was asked to give it in interval notation, the interval notation looks very much like this. I would have a squared off bracket and then the left boundary, comma, and then the right boundary and a squared off bracket. And then if I were asked to give the set notation, I want the set of all x's such that x is between these two numbers. So you show that with a 3-part inequality, and I do include those boundaries, so I need the lines under the less than symbol. Negative 3 is my left boundary, and 5 is my right boundary. So these are the different ways to show this solution set.